Welcome to this rapid review, which is part of our Solow model unit, but we're not actually going to talk about the Solow unit in this video. Instead, we're going to focus on some preliminaries that are going to help us think about the Solow model when we finally set up the equations. And the first preliminary to talk about is this idea of an intensive form. The Solow model is generally worked with in terms of per worker variables. So that would be output per worker, capital per worker, consumption per worker. And those are called the intensive form of the variables. And in order to distinguish the total amounts, for instance, total output from output per worker, we would use a lowercase letter. So as an example, if we wanted to talk about output per worker, we would have little y, output per worker. And that distinguishes it from total output, which is big Y. And then, it's sort of naturally enough, I would hope this is intuitive, this feels natural. Output per worker would be defined as output divided by number of workers. And similarly, we could have consumption per worker, that's capital C over L. We could have investment per worker, that would be total investment, capital I, divided by L, the number of workers. And finally, we could have capital per worker, which we're going to focus on a lot. That's lowercase k, which is capital K, the total amount of capital, divided by L. And one problem with the capital here, which is going to be the most common variable we work with, the lowercase k, is that it looks a lot like the capital K. So I'm kind of going to try to exaggerate how long the upper part is here so that we can always distinguish between the little k and the big K. So these are the main variables we'll be talking about. You might ask, well, if we talk about capital per worker, shouldn't we also talk about labor per worker? Because those are the two factors of production. And we could do that. So what about lowercase l? The problem is, you'll notice lowercase l would be capital L over capital L, which is just 1. The amount of workers per worker is 1. So we won't actually use that variable. We'll never have a little l because it just isn't really meaningful. So the other type of intensive form that we'll want to focus on, besides the variables we saw earlier, y, c, I, k, is we'd like to have an intensive form for the production function. We have that the total output equals capital F of k and L. It's a function of capital and labor. But what we'd like to get is a function of output, that tells us output per worker. So could we get basically, instead of having the capital F production function, could we get a little f production function? And the answer is yes. So little y is y over L. So then it equals, we can replace the y with f of k and L. And now it looks like we're kind of stuck because this expression here looks like kind of a big mess. But the key is to remember that we've assumed that the production function is constant returns to scale. And that means that if you multiply the production function times anything, that's equivalent to just multiplying all the inputs by that amount. So z here is 1 over L. And if we bring the 1 over L inside, we get f of k over L, L over L. Now L over L is just 1, so that stops being important. And k over L is the capital per worker, right? It's the little k. So we're going to rewrite this and call it little f of little k, because it's a function of little k, basically. And now we have the intensive form of the production function. It tells us output per worker is a function of capital per worker. So let's write that down. All right, so let's try to make this concrete. Let's do an example. So we have the capital FKL, our non-intensive form production function is this Cobb-Douglas, where it's k to the 1/2 times L to the 1/2. And we'd like to transform this into the intensive form production function. So the starting point is that if capital Y is k to the 1/2 times L to the 1/2, then we can get little y by dividing that by L. So it'll be k to the 1/2, L to the 1/2 over L. And now we have L to the 1/2 divided by L, so you can sort of subtract the exponents. There's a lot of different ways to simplify this, but basically you should end up with k to the 1/2 over L to the 1/2. But that's kind of a mess, so couldn't we rewrite this as K over L, sort of put the exponents on the outside and have K over L to the 1/2? But K over L is our little k, so this is really saying it's little k to the 1/2. And of course, little k to the 1/2 is just square root of k. So this production function in intensive form it turns out, is fairly simple. It's just square root of k. So this is our little f of k. So what looked like it was complicated to start with turns out to be actually fairly simple once you work through it. The last thing we should talk about is, what do we expect this f of k to look like when we graph it? And the default assumption is that there's diminishing returns to capital. So the way to define marginal product of capital for our intensive form production function is quite similar to how we defined it for the total big production function. It's going to be how much extra output per worker do you get for a little bit of extra capital per worker, a little bit of extra input. So MPK is delta F over delta K, which if you were graphing it, like on the graph below, would be the slope. And I've drawn the graph like this because if we're assuming diminishing returns, that means that the return, the marginal product, has to decrease, meaning the slope has to decrease. So this function can't be like a straight line where the slope is constant. It has to slowly bend down to reflect the slope getting smaller and smaller and smaller. This will be important because we're going to do some geometric work, some graphical work in the Solow model, and that'll involve graphing f of k like this. So we'll want to know what it looks like when we get to that point.